The astronaut orbiting the Earth is preparing to dock with a Western 5 satellite. The satellite is in a circular orbit 600 kilometers above Earth's surface, where the free fall acceleration is 8.21 meters per second. Take the radius of Earth as 6,400 kilometers, determine the speed of the satellite, and the time interval required to complete one orbit around Earth.
Okay, so for Chapter 4, Problem 32, the givens are the satellite is 600 kilometers above Earth's surface. Its free fall acceleration instead of gravity is 8.21 meters per second squared, and the radius of the Earth is 6,400 kilometers. Okay, and what we are trying to find for this problem is the speed of the satellite and the time it takes for the satellite to orbit once around Earth. Okay, now since the satellite is in free fall, the centripetal acceleration equals gravity. And so since AC equals v squared over r is equal to gravity. So now you can take the equation v squared over r equals g, and you can rearrange it to get that velocity equals the square root of the radius times gravity. And so what you see here is all the values plugged in. And so the radius is actually equal to 6,400 kilometers plus 600 kilometers. And now what a lot of people forget to do is they forget to add the 600 kilometers because they forget to take into account that the satellite is also part of the radius. I've done that multiple times. And you also multiply that by the units, which are 10 to the third meters. And now you take the gravity, which was given to us in the givens above. Instead of typical gravity is 9.80, you plug in 8.21 meters per second squared. And then you multiply all that, take the square root, and you get the answer of 7.58 times 10 to the third meters per second, equaling the velocity. Okay, now that you have found the speed of the satellite, you need to find the time it takes for the satellite to orbit Earth once. And you use the equation v equals 2 pi r over t to get that. You can rearrange that to get t equals 2 pi r over v. And then you already found everything, so it's basically just plug and chug. T equals 2 pi times the radius, which, as you see before, is 6,400 plus 600. That's where we get the 7,000 value, times 10 to the third meters, over the velocity, which was found previously as 7.58 times 10 to the third meters per second. And then once you plug that in, you get the answer of 5.80 times 10 to the third seconds. Now that is an acceptable answer. However, if you would like to change the units on that into minutes, you could rewrite that as 5.0 times 10 to the third seconds, and then divide that by 60, and then do dimensional analysis to cross off the seconds, and you get 96.7 minutes. So either is acceptable, and yeah.